Hi everyone, today we are excited to present our project, the Campus Marketplace application. So what is our application? We've developed a Campus Marketplace app that lets students buy, sell, or borrow items within their campus. Users can browse and filter listings, add their own items, and send requests to the other users. A key feature is that every listing specifies whether it's for sale or for borrowing. To ensure a safe platform, the app ensures trust with Google login, phone verification, and user ratings. The result is a simple, secure dashboard where students can easily exchange items. So first, there is no centralized platform for students to buy, sell, or borrow items just within their campus community now. Second, they rely on informal channels like group chats or social media, which makes it hard to find what they need quickly. Third, trust issues arise because users can't easily verify sellers or buyers. And fourth, item details and availability are often unclear and outdated, which leads to a confusion and waste of time. So our end users are students within campus community who want a safe and convenient way to buy, sell, or borrow items. This includes a few key groups: students looking to purchase or borrow essentials like books, electronics at affordable prices, sellers who want to easily list items they no longer need, and borrowers who prefer short-term access to an item instead of buying it new. Next, let's dive into our system design. We solve this problem through a layered system design built on the Ruby on Rails MVC framework. The front end, using HTML and CSS, provides an intuitive interface. Rails controllers handle all the requests and connect to our active record models, which represent our core idea: users, items, messages, and requests. All of this data is securely stored in PostgreSQL database. So this is our system diagram. It starts at the top left with the web browser, where the user sends HTTP requests. These requests are handled by the Rails controllers on the right. The controllers interact with the models, which in turn get or save data from database. That data is then passed to the views or templating to render the final pages for the user. For slow tasks, like sending a SMS or email, we use background jobs. This ensures the user doesn't have to wait for the page to load. And this slide shows the class diagrams of our project. The users table is central. A user can have many items. Each item belongs to a category. When a user wants an item, a request is created, which links a requester ID to an item ID. Finally, the messages table is linked to that request ID to store the conversation between the two users. So here are our design patterns. First is the MVC, which is Model View Controller, the core Rails architecture that separates our data, UI, and logic. Second is the service objects. We use this one to move complex external logic, like the SMS verification, into its own dedicated class to keep controllers clean. Third, the partials and layouts. A view layer pattern don't repeat yourself by reusing UI components. Fourth, state management. We use model attributes to track an object's status, such as draft, pending, or published. Fifth, background worker pattern. This offloads slow tasks, like sending SMS, to a background process so the user gets a fast response. Now let's take a look at the UI design. So this is the user's dashboard after they sign in. We can see a welcome message. The dashboard displays the user's listed item as cards, like old headphones and textbook. Each card clearly shows the item's condition and its status, such as for sale or for lend. Here is the Add a New Listing form. We aimed for clean and simple layout. The user fills in a title and description, and must choose one listing type, either items for sale or items for rent. They also select the condition, category, and location for more information. This mockup shows the public page for a specific user, Bob Johnson, displaying all the items they have listed, like his wooden desk chair and an Intro to Algorithms textbook. A key trust feature is visible here, the Not Verified badge. This encourages users to complete phone verification, which improves safety for everyone on the platform. So our UI design was guided by 5 core principles. First, simplicity, a clean, minimal interface focused on key actions. Second, consistency, a uniform color and layout across all the pages for a familiar experience. Third, usability, intuitive navigation and clear action buttons make the app easy to use. Fourth, feedback, confirmation messages and alerts provide users with immediate feedback. Fifth, accessibility, using high contrast, legible fonts, and properly labeled forms to ensure inclusivity. So this slide shows our framework and tools used in the process. All of the details can be found in those items.
We used AI tools throughout our development process. For UI design, tools like ChatGPT and Figma helped us come up with color schemes and layout ideas. AI also assisted with coding for issues like generating boilerplate Rails code and helping debug errors. We used it to create sample data for testing and to quickly identify and fix bugs in our Rails and Heroku setup. Overall, AI helped us work faster and solve problems more efficiently.
Of course, we faced several challenges during development. First, integration issues. Bringing all the Rails components, including models, views, and controllers together initially led to routing conflicts and dependency errors. Second, testing complexity. Configuring the testing cases for behavior-driven testing requires significant setup and troubleshooting. Third, database management. Managing migrations and the relationships between users and listing demands carefully debugging to maintain data integrity. Fourth, UI consistency. Ensuring a consistent and responsive interface across all pages took additional effort and adjustments. From those challenges, we learned 4 valuable lessons for the future. First, modular architecture. Build with clear independent components and strict naming conventions from the start to simplify integration and reduce errors. Second, design system adoption. Implementing a shared design system or component library will ensure UI consistency and speed up the development. Third, continuous learning. Actively document challenges and solutions as they happen. This creates a valuable knowledge base for the team. Fourth, define a clear MVP first. Resist scope creep by launching the smallest viable product. This allows for faster development and lets real users' feedback guide future features. And here are our future plans. We plan to integrate payments to ensure secure in-app transactions, implement a recommendation system to provide AI-based item suggestions, and add a wishlist to favorite features so users can save their items if they're interested in it, and develop dedicated mobile apps for Android or iOS to increase the accessibility. So that's all for our project, and thanks for listening.